Alrighty, guys. So this is the last video for today. I'll post up. This video is going to help you guys with working on stoichiometry practice problems. So after you viewed the moles ratio practice video and kind of went step by step and gained a little bit more confidence on doing those problems, you should be good to go into doing some stoichiometry problems. Okay. Um, Kind of like before, I'm gonna go step by step. Try to go slow and at a good pace, slow and good pace, just to make sure that you guys are following along and understanding what I am doing from the get go. Okay. So on this worksheet that you guys will be working on, make sure that you show all your work, guys, and you place your final answers in the provided boxes where you see them. Okay. So in the very first step with doing these problems, you have to make sure that your equation that you'll be using for each of these stoichiometry problems is balanced. Okay. We have to make sure that the equation is indeed balanced. Okay. So let me get my pen here and make sure that the thickness is good. There we go. Okay, so the first thing that we got to do is we got to balance this guy. Okay, so we draw our line, and then we're going to draw or write down each of the compounds. So a lot of you guys confuse this. This is not chlorine. This is not carbon and iodine. This is not an I. Okay, if it was a capital I, it would be like this. It would not be as such. Okay, this is all one thing. This is chlorine. Okay, chlorine. And then we have oxygen. Okay, so how many krypton? How many potassiums do we have? We have one. How many chlorines? One. How many oxygens? We have three. Okay, and the same thing on this side. We have K, which is one. We have Cl, which is one, and we have oxygen, which is two. Okay. So the first thing that we want to balance, it looks like, is we're going to have to balance the oxygens, okay? So remember I told you if it's not so trivial to balance both the 2 and the 3, we try to use least common factors, okay? So easiest way to do this is what's 2 times 3? It turns into the factor of 6. So in order for us to get a 6 over here, what we have to put as a coefficient, we would have to put the 3, okay? So that turns this into a 6. Okay, so if this was 6 oxygens now, how can we get 6 oxygens right here? Since we have 3, we have to multiply it by 2. So that means that we have to put a 2 right in the front. Okay, so now this changes to 6. It also changes our potassiums to 2, and it changes our chlorines to 2. Okay, so last thing, we have to balance the potassiums and the chlorines on this side. Oh, this is easy peasy, guys. So we put a 2 right up in front here. And that allows us to balance the potassiums and the chlorines. Okay, any questions there? If you do, please come see me with balancing equations, guys. This is what we've been working on last unit. This should be a little bit more, little second nature now. You're able to do this without much thought. But if you need more help, please come in. Okay, guys. We all learn at different paces. Just that we've been working on this for a little over 2 months, and this should be a little bit more easier compared to when we first started. Okay. Uh, so yeah, just keep going. Okay. So now we have our balanced equation. Here we have our coefficients 2, 2, and 3. Okay. So let's go ahead and continue. So we're gonna need we're gonna need those coefficients right now for this next problem. Okay. So like I mentioned on our moles ratio practice problems, we should always circle the unknowns, what we're looking for. So how many grams of KClO3 are needed to make 30 grams of potassium chloride? Okay, so what are we looking for? The question is asking us how many grams of potassium chlorate. That's what it's asking us. Okay, right after how many, typically it's going to give you what you're looking for. Okay, so that's our first step. we're going to circle what we're looking for. And then we're going to underline what's given. Okay, that's our second step. We're going to underline what's given. Okay, so now what's given is right here, which is perfect. And then we're able to go on and so the first step that we are going to want to be doing is, let me change the color, is we want to go from grams to moles, okay? Because what's given is grams, okay? But we don't want to be working in grams because remember, it's easier to go from one unit to another if we are using moles, okay? So we need to be in moles. This is very important, okay? We have to be in moles. So in order for us to get into moles, we have to convert our 30 grams of potassium chloride into moles. Okay, so like kind of how what we talked about in class today. How can we go from grams to moles? We could use the molar mass. Okay, and in order for us to do that, remember we have to look for the molar mass of KCl. So the molar mass for KCl is, for K, how many K's do we have? We only have one. We're going to multiply it by its atomic mass, which is 39.1 grams per mole. And then we have chlorine. How many do we have? One. And we're going to multiply it by its molar mass, and we get 35.45 grams per mole. So remember, each of these values right here we can find on the periodic table, okay? And then after we do the math and we add all these up, we get 74.55 grams over 1 mole of KCl. Okay. So the next thing that we do is we multiply by this molar mass conversion factor. Okay. But we want to cancel out the grams. Okay. We want to go to moles. So that means we're going to have to rearrange this conversion factor. Okay, so the 1 mole goes on top because that's what we're looking for. And then the 74.55 grams of KCl goes on top. Okay, so we should put moles of KCl up here too. Okay, because that's what we want. All right. So then the next thing that we should be doing is typing this in our calculators. Okay, so we got 30 divided by 74.55. That gives us 0.402 moles. Okay, so this gives us equals 0.40 moles of KCl. Okay, and that's perfect. That's exactly what we want. All right. Now we can use this value for step 2. Okay, so let's go ahead and scroll up a little bit. So for step 2, okay, we're going to use our 0.4, we rewrite this, moles of KCl. And now what we're going to want to do is we're going to want to go from moles to moles. So we want to go from the moles of KCl to, what are we looking for? Moles of KClO3. So we want to go to moles of KClO3. KClO3. That's what we want to do next. So in order for us to do that, we have to now find our mole. Whoa, what happened? There we go. We have to find our mole ratio. Okay, so now we have to find the mole ratio between KCl and KClO3. So now let's look at KCl. KCl has 2. So we have a mole ratio of 2 moles of KCl over 2 moles of KClO3. Oh, this is beautiful because look at, we have 2 on the bottom, 2 on top. What can we do? We could reduce fractions. Then we just get 1 mole of KCl over 1 mole of KClO3. Okay, so then now what we could do is put in our mole ratio. It was 1 mole of KCl over 1 mole of KClO3. Uh-oh, some of you should be having your ears ringing because this is not correct. We cannot cancel our units. Mole of KCl should be on the bottom. So what we should do is we should rewrite this as KClO3 on top and moles of KCl on the bottom so that we could indeed cancel our units. And that will give us 0.4 moles of KClO3. Okay, so now our last step, step 3, is we have to go from moles of KClO3 to grams of KClO3. Okay, so that's the very last step. So then we take our moles of KClO3, 0.4 moles of KClO3. We write that over 1. And now, in order for us to go from moles to grams, what are we using again, everybody? We're using the molar mass. Okay, that's what we're using next. I hope this Word document doesn't crash on me. That's what we're using next, okay? So, let's find our molar mass. We have a K, we have Cl, we have an O. Cl, we only have 1, and that is 35.45 times 35.45 grams per mole. Then K, we only have 1, and we multiply that with 39.1 grams per mole. And in oxygen, we have 3 of those guys, and we multiply that by 16, and that gives us 48 grams per mole. When we add all these up together, we should get 122.55 grams over of KClO3 over 1 mole of KClO3. Okay? Now what we could do is fit in our conversion factor right in here. Oh, that will work out perfectly because look at mole of KClO3 is on the bottom and mole of KCl3 is on top of this guy. So we could easily cancel units. Okay, so we write our line and we have 122. Uh-oh, what happened? 122.55 grams of KClO3 over 1 mole of KClO3. And then here you see that the moles of KClO3 cancel with moles of KClO3. And then we should finally reach an answer of 0.4. Now we just got to do this multiplication times 122.5. We should get 49.02 as our final answer. Okay, so it's 49.02 grams of KClO3. Okay, guys. So that is the steps that are, those are the steps, sorry about my language. Those are the steps required to do these problems, okay? So like I said, understanding the mole ratio is very important when you're doing these problems, okay? Now you have the correct tools for you guys to be able to continue on with the worksheet. And if you need any help or any questions, please feel free to come see me, and I can give you guys a hand. Alrighty? Have a good day.